Adding our block did work quite well in the last video, and we could already impact the node with our bird. What we're still missing is the functionality that when we hit the block with our bird, we should be damaging it. We did implement some requirements for this in our block node with the health and damage threshold properties. But we did not really add how the node is impacted. To complete this, I will go back to the node class, so the block class, where we are going to add another method right at the bottom. I will call this method impact, and it will get a parameter force of type integer. From the game scene, I will, in the case of a physical contact of bird and block nodes, call this method on the impacted block and damage it appropriately. Inside of the method, I will begin by writing health minus equals force to just subtract the impact force from the health. To maybe be able to see this a little better, I will also add a print statement to print out the current health value to the console so that we can check it. I will also check two more things here and begin by writing if health is less than 1, and in this case we did destroy our block. In this case, all I want to do for now is remove the block. We can obviously do that by calling remove from parent. I will also check else if health is less than damage threshold, and if this is true, we have damaged our block for more than half of its health points. And later we will use this part to change the texture to a more damaged one. For now, just to show this, I will set the color property to UIColor.red so that we can see if this works. Now that we have this impact method, I can go into my game scene where I will add an extension to handle the physics contacts in my scene. Let's do it above the gesture extension by writing extension, game scene, and then adopting the SK Physics Contact Delegate protocol for our scene. Inside of this extension, we will now handle contacts in our game using the didBeginContact method that will get called if two physics bodies with the appropriate category bit masks come into contact. Just like we did it before, I will begin by defining a constant mask, which will contain the bit mask of the contact that has happened by setting it to contact.bodyA.categoryBitMask, bitwise or contact.bodyB.categoryBitMask. I can then add a switch statement for this mask and compare it to the known contacts in my scene. I will begin with the case physicsCategory.bird, bitwise or physicsCategory.block, which would be a contact between the bird and a block. The first thing we need to check is which one of our contact nodes is the block and which is the bird. We can do that by writing if let block is contact.bodyB.node as block, in which case we would save the node of body B as a block node. Else if I'll write let block is contact.bodyA.node as block, so that we can now use these block constants to impact our block no matter which node it is. We will do exactly the same in both cases, obviously, and that is calling the impact method with the block. So let's write block.impact. And now I need to pass an integer for how hard this block was hit. It is pretty convenient for us that we actually have a property of the contact parameter here that specifies the collision impulse, which is pretty much how hard this contact was, or this impact. I will have to cast it as an integer though by writing int and then contact.collisionImpulse. This will just pass an integer with the appropriate value to the impact method, which will then damage the block. I can just copy this and paste it in the other part of the if statement as well, if the block is in the body A node, but this should now damage our block correctly. Before we can run the app, there's a small step missing, and if you pay close attention, you might already know what I mean. In order for our didBegin method to actually be called, I will scroll all the way up to my didMoveToView method, where I will write at the top, before calling anything else, set physicsworld.contactDelegate to self, so that the contacts are actually handled in the game scene itself, and our code we just wrote at the bottom actually gets called. So let's run the app and see if it works, and we are able to damage our block. We can check this by seeing if we get the appropriate output in our console, obviously. Alright, I'll just launch my first bird right into the block, just like we did before, and nothing different happened. If I now launch the second bird though, our block turned red, so we apparently damaged it below the threshold. And finally, if I hit it hard with the last one, I can see that my block node disappeared. So we actually managed to destroy it. I can also see, if I take a look at my console, that we have the correct prints there, stating the current health of our block during the hits or after the hits. I now have a little challenge for you, which will hopefully make you a little more confident in using the physics delegate. I now want you to add the other cases for existing contacts in our game, and by that I mean those that we want to react to in any way. These will be contact between two block nodes. In this case, we also want to damage them, since if we just throw around our blocks, they should naturally also take damage from colliding with each other. The next will be contact between the blocks and the edge, since dropping it to the ground should also damage the blocks. And for you to check the contact between the bird and the edges. And we just want to make sure that as soon as the bird hits a wall or the ground, we will set its flying property to false. Why we need this will be clear later on, but before watching the next video, why don't you give it a try and try to add these 3 cases to our didBegin contact method. But if you feel like this might be too much, don't worry, I will explain it step by step for you in the next video.